A demultiplexer is a device or it is a combinational logic circuit designed to switch one common input line to several separate output lines. So if I draw the logic symbol for a demultiplexer, we can see that it have only one input. Let this be the input. Input is represented as I. Suppose we have 4 output lines and it is represented as A, B, C and D. And this is known as 1:4 Demux. Demultiplexer is also known as Demux in short. So a demultiplexer is a combinational circuit. So this is a combinational circuit. To be specific, we can say it is a combinational logic circuit. It is combinational because there is no memory element, or the output does not depend on the past input or previous history or previous output. Output depends only on the present input. That's why it is known as combinational circuit or combinational logic circuit. So to going back to the definition, a demultiplexer is a combinational logic circuit and it is designed to switch one common input line, that is this input, to one of the several separate output line. That means it will switch this input to any of this one output at a time. A single input is transferred to any of the one output at a time. That means suppose this is the single input, we have 4 output. At a time this may be sent to A only. That means input is available only in A. It is not available in the other 3 outputs. At a later time we can provide this input to another output, that means to C. We can provide this input to C. That means it is not available in A, B and D. It is available only in output line C. So we can switch the input to any one of the output at a particular time. And this is known as a demultiplexer. So if we draw the logic diagram in a more specific way, it will be like this. So we have 1:4 Demux. We have an input represented as I. This is input. We have 4 outputs, namely A, B, C and D. And in order to route the input to particular output, we have 2 control lines. We will say it as select lines, S1 and S0. Why there is only 2 select lines? Because we have only 4 outputs. We have only 4 output lines. So with the help of 2 select lines, we can control 4 output lines. Because 2 selected means 2⁻²² is 4 combinations. That means there is only 4 selected. We can control all 4 output lines with the help of 2 select line. If we have 8 output line, if we have 8 output line, we need 3 select line or control line. That is 2 raised to 3 is 8. This 2 indicates the binary base, that means 0 and 1. We have only 2 bases. And this 3 indicates number of select line. So depending upon the number of select line, depending upon the number of output line, we have to increase the number of select line. So in the case we have just drawn, we have only 4 output line, we need only 2 select line. If there is only 2 select line, if there is only 2 output line, we need only 1 select line, because 2 raised to 1 is equal to 2 output lines. If we have 16 output line, we need 2 raised to 4 is 16, so we need 4 select line. So this is the logic diagram, logic symbol of a 1:4 demultiplexer. Logic symbol for demultiplexer. Logic symbol. Now we will see the truth table of a demultiplexer. So we will draw that table. So those 2 select lines are S1 and S0, as we have seen in the diagram. This will control the circuit. This will control the demultiplexer. And we have the output. In the output we have 4 lines A, B, C. So this is the truth table headers. This is the select line or select input, and this is the output. First we will see 0, 0. Suppose S1 is 0 and S0 is 0. We can decide at that time, that is when S1 is 0 and S0 is 0, input should go to which channel we can decide. Either it should go to A, B, C or D. So for simplicity we will take it in the order. When it is 0, 0, we will design such that input will appear in the output A. The next case 0, 1, input will appear in B. In the second case, that means 0, 1. In the next case 1, 0, input will appear in C. In the next case input will appear in D. So we will write the truth table accordingly. So 0, 0 means output A will be active. Output line A will be active. Input will enter or come out through output line A. 0, 1 B, 1, 0 C, and 1, 1 D. So now we will write the Boolean expression or logic expression. Output Y is equal to, so we will write output is represented as Y. Output Y is equal to, we will get the output in A only if S1 equal to 0 and S0 equal to 0. In all other cases, we will not get any output in A. So we will get output in A only when S1 is 0, only when S1 is 0, that is S1 bar, and S0 is 0. So when both are 0, we will get output in A. Or another case, we will get output in B only when S1 is 0 and S0 is 1. If it is 1, we will not give the bar. Or we will get the output in C also. We will get output in C only when S1 is 1 and S0 is 0. And finally, in some other time, we will get output in D. That's only when S1 is 1 and S0 is 1. So this is the logic expression or logic equation of a 1:4 demultiplexer. So similarly, we can also draw or design 1:8 Demux. So in 1:8 Demux, we will be having single input, again single input, but we have 8 output lines because it is 1:8 Demux. This is 1, 2, 3, 4, 5, 6, 7. We need one more. And we need 3 select lines because we need to select 8 output lines, S2, S1 and S0. And remaining all the process is same as we have seen in the 1:4 output line. We have to draw the truth table and write the expression as we have done in 1:4 Demux.